Hi, it's Dr. Myers here, and this is going to be all about the theory of the firm and provide for you I hope, a very solid introduction to the theory of the firm. And by doing this, I hope we can make the more simplified model in the text come alive and be a lot richer. So when you're in a firm, you have to make decisions, production decisions, not only what to produce, but how to produce it, and what kind of price you're going to charge, and all those sort of things that you see there on the screen. You also have to contemplate what kind of market structure you're in. You know, do you have major competitors that are constantly at your heels? Are you pretty independent? Do you have a product that's very dissimilar for others? Do you have any kind of protection that firms are not going to be able to enter your market? All of this plays a vital role. So when we begin to take a look at what we're seeing here is we want to look at production and how we get to profit, right? So managerial economics is a course that's quite a step up from this one. It deals a lot with optimization, mathematical optimization, trying to figure out what the model is and does it fit our firm? Have we used some design tools to figure out what is the structure of our production relationships? Can we use that then to analyze? So in order to make decisions, we're combining both economics and what I would like to call data science, the data analytics, the whole decision sciences paradigm that would help us use actual data from the firm, from other firms, from the industry to help inform our decisions and come to a point at the end where we actually can implement those decisions. So to figure out all of this, the first thing is how do we value a firm? And to value a firm, there's three main components. And the first is the idea of what is the riskiness of the firm? And let's come back to that in a second. We then look at what is the value of the total revenue? Well, a firm has to do demand and demand forecasting. They have to do pricing, and they have to do new product development, and that's all going to be affecting their revenue stream. And what we want to try to understand is what does that look like in an economic model, and doesn't take away from the fact that to get the actual data, you're going to have to not only design that, put up some kind of collection mechanism for the data, and actually take a look at it through the lens of your own particular firm. But these principles that we're going to talk about, we're going to hold firm. The second is what about the cost? And this comes down to your production techniques and how are cost interplaying with those production techniques. You know, how expensive is your labor? How expensive is your capital? What kind of costs are coming up this quarter and next and what have you. And again, what's your process development to sort of keep up and actually get ahead of things to bring even more cost efficiency. So between total revenue and total cost, we determine your profitability. And then bringing in the riskiness, which we put off for a second, was now what is the probability that we're actually going to be able to achieve that actual profitability? So in chapter 16 and 17 of the text that I'm using here as we do this video, we're going to talk about things like imperfect information, asymmetrical information where people have different levels of information. You know, buyers may have more than sellers, sellers may have more than buyers, and so forth. And also, what about insurance under imperfect information? Our perfectly competitive model that we will start off with as we turn to market structures, probably in the next lecture or set of readings, we're going to be asking you to say in a perfect competitive market, everybody has perfect information. No, that's not true in most cases. We have quite imperfect information. And this leads to some serious problems called adverse selection, moral hazard, and so forth. And we will address those later in the course. So first, understanding the firm, your production techniques lead you to a technical efficiency. So by that I mean, just think of like the engineering process of getting your product made. are you doing it in the most technically efficient way? Could you reduce, some material, or substitute another material, or create a process that's a little faster? And all of these might bring you a more technically efficient thing. And of course, everybody wants to do this, and this is kind of the engineering side. How do we get it done? Then if we take a look at the factor prices, and we bring in and say, well, we're going to use this much labor in our technique, and we're going to use this much capital. Now, understanding the factor prices, we start building the cost of the production, and that's where we get into economic efficiency concerns. So as you read through the text and our other material, you'll see that that efficiency is different depending upon whether we're talking about economic efficiency or technical. And then on the product demand, we're looking at, you know, what kind of price are consumers willing to pay, and and certainly are they able to pay? We need to know what our market is out there, and what our best pricing strategies are, and so forth. And indeed, does the industry, does the regulatory environment, the legal environment, does it limit our ability to transact business, get the price in, and so forth? And again, between the two, we have profitability. This all comes from your book for the most part. These are tables out of your text, which talk about how do we calculate production cost. And I'm going to come to all of this in great detail, but over in the corner, we see the short run average and marginal cost curves, where frankly most of the action takes place. Down at the bottom, we see formulas for how do we calculate total, average, and marginal cost based upon whether those costs are variable or fixed. So there are 6 formulas right there. I'm going to add to that. So total cost, which you see the graph in the bottom, is typically rising. It starts with cost at 0, we call fixed. The fixed costs are not affected by production. So at Q equals 0 or Q equal 100, we're going to have the same fixed cost. And that's why over in the red box, you see a K with a bar. The typical short run production model that we're going to use to teach you about all this is that capital is fixed. You make a decision, and in the short run, you're limited by the capital that you have. And you can't vary that on a daily basis, monthly basis, sometimes even a yearly basis. But labor you can vary. We call that the variable factor. So together, over in the red box on the right, you see quantity, that's our output, is produced by some function, and that's all that F stands for, is some function of labor and capital. So take your technical process that you've developed, and we hope you're technically efficient. You throw labor and capital into this function, you shake it up and pour out an output. The output then can be sold. So in the second line in the red box, you take the total revenue, which is price times the output. So what can you sell it for? When you transact business, there's your revenue stream. And the cost, in a nutshell here, is I hired labor, I have to pay them W, a wage rate. I hire capital, and I have to pay it a price of capital, what we call rental rate, because we're not charging off the entire amount of capital, we're charging only the service on that capital. And I think you'll read more about that. So we take the difference between total revenue to total cost, and we will get our profitability. But that red box, that production function, is tied up there with the labor and quantity that you see in the table. That as we hire one worker with fixed capital, we produce 16 units. If we add another worker, we can produce 40. We add another, we produce 60. And all of the other values stem from that. And here's where we want to go. So let's take a look, and this is from the Allen Managerial Economics text to sort of give you a look into this. So a theoretical model is what you saw on the last screen. Sure, we had some data to illustrate it, but it was a theoretical model where quantity is a function of labor and capital. We don't always know exactly what that production function is. In your business, you may have a mathematical ability to put that together. But for now, let's say that's just a functional notation. It reminds us what's important. And we can look at average product of labor. And the reason for that is since capital is fixed, the only thing that can vary output is the amount of labor that we put in. So marginal, though, is a very different thing, which says if we hire one more unit of labor, how much more output do we get? One of the values here is marginal product can go negative. It can be a signal to us that if we hire another worker, our output will go down. But average product, take a look at it. Quantity is positive, labor is positive, that ratio is always positive. While average product may fall, it will never go negative. So it doesn't give us as perfect a signal that we're going too far. We're out at the margin and we ought not to be there because obviously if we hire more workers and marginal product goes negative, then we're saying I have extra labor cost and even less revenue than before I hired them. That's a very bad situation. So a mathematical model would be in the second case. TP is just total product. That's how it's written sometimes. Is equal to output. And we have a cubic function here that's suggested by Allen's managerial economics book is example. And it just says that his mathematical expression is a cubic function of labor where a is always 0. Now, the reason I put a there is any cubic function has an intercept, but there's no intercept in output. Why? Because the output would be, if you look at that first equation, a plus bl and so forth, if labor is 0, that equation would say you would produce A. Well, that's ridiculous. If you have no variable factor, you have no workers, all you have is fixed capital, you produce 0. So A is always 0, and we're going to ignore it from this point on. Average product to labor, the second line there in the middle, the mathematical model, same as we see in the theoretical, but because we have a formula, we can just take that formula now and divide through by labor. So we take Q and divide it by L, and we end up with B because L has canceled, CL because L squared divided by L is only 1, and so forth. And I added something. Average product must all be 0 now, or greater than 0. Why do I add that? Because if we don't have any parameterization and we just go fishing and say, well, I wonder if B is this amount, C is that amount, we know our model is bad if we ever get average product to come up with negative. So that has to be positive always. And then marginal product, this is the total derivative of the quantity function and with respect to L, and that is B plus 2 times CL to the 2 minus 1 plus 3 D, the parameter, L to the 3 minus 1 or 2, so it's a squared term. Now you can calculate, because we have a mathematical model, you can calculate it directly, the marginal cost, using that math, or you can, say in an Excel sheet, you can calculate that using something that looks a little bit like a midpoint formula for the elasticity, if you remember that. So let's say I wanted to know the marginal product for L, and L was equal to 2. So we have a simple model L0, 1, 2, 3, 4, and 5, and subsequently the amount of output. So for L equals 2, the formula then would be, let's look and see what is the quantity at L equal 3, since we have the whole table, and let's subtract L equals 1, that quantity, and then divide it by 3 minus 1. And what does that do? It centers the productivity between the third and the first, and that's what we're looking at, the second. Now, we could look at just 2 minus 1 or 1 minus, sorry, we're looking at number 2. We could look at 2 minus 1 as a change, or we could look at 3 minus 2 at a change. The problem is we'll get different numbers. If we do it this way, we will center on the L equal 2 point, and if we then use this math to go on and try to look for some equalities and so forth that we expect in this data, it's going to line up. In fact, we're going to show you in a minute, we're going to use both of those methods and come up with the same thing. Down at the bottom is the actual example, the actual formula from Allen's book. 30L plus 20L squared minus L3 is quantity. And then the next two lines are defined first by dividing Q by L for the average product, and the second by taking the derivative of Q with respect to L to get the other part. Now, how do we optimize? And what are we trying to do? I want to optimize on the number of units that I have. I want to find the best possible case of using labor. Now remember, labor is the only thing I can change here in this simple model, and I want to know how many workers to hire in order that I have the greatest position here, ultimately profitability. So what do? I take my quantity is equal to function of labor and capital is fixed, and I recognize that total revenue is price times quantity, and then there about in the middle of the screen you have two formulas. Marginal revenue, which I believe you've seen, is the change in total revenue, where total revenue is price times quantity, divided by quantity. And marginal product of labor is the change in output with respect to a change in labor. So the marginal product of labor says if I hire an additional laborer, how much output will I produce? Marginal revenue says if I hire an additional quantity, or make it not higher, but make it different, an additional unit of quantity, how much extra revenue do I get? We put those two together, and you can see in the red highlighted there area there that we have something called the marginal revenue product, which is if I hire a worker, how much extra revenue do I get? And it comes through two stages. If I hire a worker, I get more output. That's marginal product. And if I get more output, I get more revenue. That's marginal revenue. And we therefore see a marriage between the product market, which is marginal revenue, we're producing a product, and the factor market, which is how productive are our workers. So we can actually value those workers and say marginal revenue product is really the value of that worker. In perfect competition, chapter 8 for us, because elasticity of demand is infinite, the value of the marginal product, the marginal revenue product here of labor, is price times marginal product. But in imperfect competition, and I covered this when we were talking about elasticities, that in imperfect competition, the elasticity of demand's not infinite, and it enters into this formula, and the marginal revenue of product of labor is equal to price times 1 plus 1 I think that's minus 1 over the elasticity of demand times the marginal product of labor. So again, we're looking for that optimal level. How do we get there? Well, we need another thing, and that is how much do we spend on labor? So we're going to be paying a wage rate, right, for that labor, but what is the extra expenditure of hiring an extra worker? Well, as it turns out, if it's a competitive market, it's just the wage rate. But how do we see that? It's the marginal expenditure on labor is equal to the change in total cost divided by the change in labor. So to maximize the use of a variable input like labor, we should hire as long as the extra expenditure on labor is no greater than the extra revenue attributed to that labor. That is, hire as long as the marginal revenue product of labor, that's the value of the worker, is greater than the marginal expenditure on labor, and that will help us get to the optimum level of employment, which actually occurs when those are equal. That last line, the marginal revenue product of labor is equal to marginal expense on labor, is the profit maximizing hiring decision. That is an optimum position to be in. So how do we interpret that? I got the formula, I know what that is. But take a look at what that formula is. So I take marginal revenue product of labor in the middle there and show you how it's related to marginal revenue and marginal product. And then I have marginal expense in the next line and how that's related to marginal product also and marginal cost. And if I then take the original equation, I said, how are we going to interpret this equation? Marginal revenue product of labor equals marginal efficiency of labor. And I write down what their definitions are. Hey, the marginal products cancel, and I'm left with an output decision, which is if marginal revenue equals marginal cost, we have reached profit maximization. So the marginal analysis that we've been talking about all the way through comes here as well. Marginal revenue to the firm, that's the marginal benefit. Marginal cost, of course, is the marginal cost. And as long as the marginal cost exceeds or equals the marginal cost, we should continue to produce. And we do actually produce all the way to this point. So this is about 20 minutes. I'm going to stop here and I'm going to put a part 2 out just so that these don't get too long, and you can replay these again or look at them in order, and I will see you in class.